From iPower Energy System Research Center, the University of Electro-Communications, Tokyo, Japan.
The Honorable Professor TAWATCHAI CHARINPANITKUL from Chulalongkorn University, Thailand.
The Honorable Professor Noordin Muhammad Yusuf from University Teknologi Malaysia.
The Honorable Professor Dr. Ingenieur Bondan Tiara Sofyan, MSI, from Expert Staff of National Resilience Institute, Indonesia.
And also, all of the participants and presenters of this International Conference 2021.
The first event is singing the national anthem, Indonesia Raya. All of the participants, please stand up. Thanks for attention. All of the participants, please sit down.
Ladies and gentlemen, this conference is to bring together academia, researchers, business entrepreneurs, practitioners, and policymakers who are responsible for technology sophisticated solutions through leveraging advanced technology and engineering, which is for our own competitive future.
First of all, we would like to invite the Chief Committee of this international conference, Nofriani Amalia STMT, to deliver the report of IC-EMAMM 2021. To Mrs. Nofriani, the pleasant time is yours.
Assalamualaikum warahmatullahi wabarakatuh and good morning. First of all, praise be to God Almighty, Allah Subhanahu wa Ta'ala, for the blessing in this time, opportunity, and our help. Excellencies, college, ladies and gentlemen, on behalf of the committee, I warmly welcome all of you at the International Conference on Energy, Manufacture, Advanced Material and Mechatronics 2021, organized by Mechanical Engineering Department, Faculty of Engineering, Hasanuddin University, Indonesia. We are delighted to be able to hold this conference, even though it is being held virtually. We do hope that this conference will inspire academia, researchers, and policymakers to realize the role of mechanical engineer in achieving sustainable development goals. In this conference, our technical program will conduct with 4 keynote speech and 56 technical papers split between 4 parallel oral sessions. All of the papers will be published in AIP conference proceeding after reviewing process, and around 80 institutions from Indonesia and other Asia countries are involving in this event. This conference is the result of the hard work, support, and dedication of a number of parties. First, we would like to send our sincere gratitude to the Rector of Hasanuddin University, Dean of Engineering Faculty, and Head of Mechanical Engineering Department for the support. We are grateful to the keynote speakers, Professor SHUZI HAYASE from University of Electro-Communications, Tokyo, Japan, Professor TAWATCHAI CHARINPANITKUL from Chulalongkorn University, Thailand, Professor Noordin Muhammad Yusuf from University Technology, Malaysia, and Professor Bondan Tiara Sofyan from National Resilience Institute, Indonesia. We are also fortunate to have the support from the supporting organization, the Institution of Engineers Indonesia, Makassar Chapter, PT PLN, Bank Sulsel Bar, and PT Sulsel Citra Indonesia. Thank you to all of the authors and presenters who are the backbone of this conference. Finally, recognition should go to the committee members for the hard work, collaboration, and dedication for this event. We are expecting this conference will also provide us better linkage, friendship, and collaboration. Thank you for being here with us. We value your presence at this conference. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Mrs. Nofriani, for the speech.
Excellencies, distinguished guests, participants, ladies and gentlemen. Now, we are going to listen to the opening speech from the Head Department of Mechanical Engineering of Hasanuddin University. To Mr. Jalal, the pleasant time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning. It is a great honor for us to welcome all of you at the International Conference on Energy, Manufacture, Advanced Material and Mechatronics 2020. This conference organized by Mechanical Engineering Department, Engineering Faculty of Hasanuddin University. First of all, we would like to express our most sincere gratitude to Governor of South Sulawesi, Vice Rector of Hasanuddin University, Vice Dean of Engineering Faculty who joined today in this conference room, Prof. Baharudin, and all department head of Engineering Faculty. We are also grateful to the keynote speaker, Prof. SHUZI HAYASE from University of Electro-Communications, Tokyo, Japan, Professor TAWATCHAI CHARINPANITKUL from Chulalongkorn University, Thailand, Professor Noordin Muhammad Yusuf from University Technology, Malaysia, Prof. Bondan Tiara Sofyan, National Resilience Institute of Indonesia. Also, a very warm welcome to all authors and presenters. we are expecting this conference will provide us better linkage, friendship, and collaboration to all outdoors and all the world, and also will significantly inspire academia and researcher and policymaker. Finally, thank you to the all committee for the report, hard work, collaboration, and dedication so that this conference can be held today. And also thank you very much for the sponsoring organization, the Institution of Engineer Indonesia, Makassar Chapter, PT PLN, Bank Sulselbal, and PT Sulsel Citra Indonesia. Thank you very much. Enjoy this conference. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you very much, Mr. Jalal, for the enlightening speech.
Moving on, we are going to listen to the opening speech from the Vice Dean of Engineering Faculty of Hasanuddin University, Professor Baharuddin ST.MR, PhD. Please welcome. The place and time is yours.
Your Excellency, Vice Governor South Sulawesi Province, Andi Sudirman Sulaiman, ST, the Honorable Vice Rector for Research, Innovation, and Partnership, Professor Masroon Nasi, the Honorable Keynote Speaker, Professor SHUZI HAYASE from the University of Electro-Communications, Tokyo, Japan, the Honorable Professor TAWATCHAI, CHARINPANITKUL from Chulalongkorn University, Thailand, the Honorable Professor Noordin Muhammad Yusuf, School of Mechanical Engineering, University Technology, Malaysia, the Honorable Professor Bondan Tiara Sofyan, National Resilience Institute, Indonesia, the Honorable Head of Department, Mechanical Engineering, the Honorable all Professor, lecturers from the Faculty of Engineering, Hasanuddin University, the Honorable all speakers, presenters, participants, and organizing committee of this international conference. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. First of all, let us thank to Almighty God, Allah Subhanahu wa Ta'ala, for giving us good health and time to attend this very important conference, even though some of us join the conference via Zoom meeting. The Dean of Faculty of Engineering, Professor Muhammad Arsyad Taha, apologizes because he cannot attend this conference, because there is another activity that are as important as this activity. On behalf of the Dean of Faculty of Engineering, I would like to warmly welcome all of you to this international conference on energy, manufacture, advanced material and mechatronics 2021. The conference is managed by the Department of Mechanical, Faculty of Engineering, Hasanuddin University. The theme of this conference is the role of mechanical engineers in achieving sustainable development goals through technology and innovation. The Sustainable Development Goals, SDGs, established by the United Nations in 2015, consist of 17 global goals with 169 targets. This includes the economic growth, that is production and employment, clean energy industries and infrastructure, and other environmental sustainability. And the effective regulation rules and the governance. Technology development, which is supported by engineers, especially the mechanical engineers, plays a significant role in achieving SDGs target by improving the efficiency and effectiveness of the new and more sustainable ways of development. The creation of new technologies that foster research and stimulate innovation is thus required. This process can be boosted by strengthening knowledge sharing and collaboration among stakeholders in both national and international contexts. On behalf of the Dean of Faculty of Engineering, I would like again express my sincerely thanks to all keynote speakers and participants and also the presenter for sharing your knowledge, expertise, and experience in this conference. Last but not least, I would like to thank the organizing committee, all parties, including lecturers, administrative staff, students, and all participants for arranging this and attending this seminar. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, the Vice Dean of Engineering Faculty of Hasanuddin University.
It is now my pleasure to introduce the Vice Rector of Research, Innovation and Partnership of Hasanuddin University, Professor Dr. Muhammad Nasrul Masih, PhD, to deliver the opening speech. And afterward, we would like to request the Vice Rector to officially open the IC-EMAMM 2021. Ladies and gentlemen, please welcome the Vice Rector of Hasanuddin University.
The Honorable Dean, Faculty of Engineering, Universitas Hasanuddin, the Honorable Head of Mechanical Engineering Department, the Honorable keynote speakers, distinguished guests and participants. Assalamualaikum warahmatullahi wabarakatuh, and good morning, ladies and gentlemen. First, let us send our grateful and praise to the Almighty God, Allah Subhanahu wa Ta'ala, for all His blessing, grace, and mercies that have made us possible together here in excellent condition and health. Ladies and gentlemen, it is an honor and privilege for me to welcome all of you to the International Conference on Energy, Manufacture, Advanced Material and Mechatronics 2021, conducted by Department of Mechanical Engineering, Universitas Hasanuddin. On behalf of Universitas Hasanuddin, I would like to take this opportunity to express my deepest appreciation to our distinguished keynote speakers. Professor SHUZI HAYASE from the University of Electro-Communications, Japan. Professor TAWATCHAI CHARINPANITKUL from Chulalongkorn University, Thailand. Professor Noordin Muhammad Yusuf from University Technology Malaysia, and Professor Dr. Engineer Bondan Tiara Sofyan, MSc, from Indonesian National Resilience Institute. Thank you very much for accepting our invitation to be our speakers today. Ladies and gentlemen, the theme of conference today is the role of mechanical engineers in achieving sustainable development goals through technology and innovation. Mechanical engineering is one of the broadest engineering disciplines. It combines physics, engineering, and mathematics principles, which are then implemented in the analysis, design, manufacturing, and maintenance of machinery. Mechanical engineers play key roles in a wide range of industry, including automotive, aerospace, biotechnology, computer, electronics, micro electromechanical system, energy conversion, robotics, and automation and manufacturing. In 2015, the United Nations introduced an agenda for sustainable development, and this agenda announced 17 sustainable development goals. The theme sustainable development focus attention on generational equity along with economic, environmental, as well as social issues. A prerequisite for development is growing, and that is directly related to the production or output of a country. If production is done via a sustainable path, it can maintain the sustainability of development. If we take a closer look at the rules and responsibility of mechanical engineering, this discipline can be considered as the merging point of all other engineering disciplines. Therefore, mechanical engineers play a vital role in developing in countries across the globe. The topic of this conference will ensure the role, responsibilities, and necessary contribution required by mechanical engineers to achieve sustainable development in time through technology and innovation. In accordance with the vision and mission of Universitas Hasanuddin, this is to become a world-class research university. This international conference is one among many. It is part of our concern on contribution of quality of life. Hopefully, we all can significantly give more contribution to the nation at advancement. Distinguished participants, ladies and gentlemen, thank you for being here. Welcome and enjoy the conference. Finally, I would like to conclude my remark and to officially open this conference. Bismillahirrahmanirrahim. With the blessing of Allah, God Almighty, I officially open this conference. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. The Honorable
Thank you very much, the Vice Rector of Hasanuddin University, to have officially opened this international conference.
Now, we are going to see a salutation video from Sulawesi PLT Governor Andi Sudirman Sulaiman ST. Let's watch the video.
Bismillah, assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semuanya. Peran seorang mechanical engineer saat ini sangat diperlukan guna mendukung pembangunan berkelanjutan. Oleh karena itu, seorang engineer dituntut berwawasan luas, menguasai teknologi dan berinovasi. Saya Andi Sudirman Sulaiman, pelaksana tugas Gubernur Sulawesi Selatan, mendukung dan mengapresiasi atas terselenggaranya International Conference of Energy, Manufacture, Advanced Material and Mechatronics, IC-EMAMM tahun 2021. Harapan saya dengan diadakannya seminar ini dapat menghasilkan pemikiran-pemikiran yang revolusioner, kritis dan inovatif dalam mendukung pembangunan berkelanjutan dan juga memberikan kontribusi positif bagi bangsa dan juga terkhusus bagi Sulawesi Selatan yang kita cintai. Bersinergi bersama pemerintah Provinsi Selatan adalah harapan kita bersama dan sukses Ki, selamat Ki. Assalamualaikum warahmatullahi wabarakatuh. Hidup teknik.
Thank you very much, Mr. Sudirman, for the speech.
Moving on, we would see the traditional four ethnic dance from Sulawesi. To our amazing dancers, the place and time is yours.
sembah-sembah. Ku esang bara anta pamisa pena anta sirante pada ulembangan ton dukta lepongan bulan tondo tasusina tondo toraya inde Batan kada di pomate ungkolianton duka.
Before we go to the next session, we would you like to say thank you to our honorable sponsorship, Profesi Insinyur Masar Chapter Makassar,
Perusahaan Listrik Negara,
Bank Sulselbar.
and PT Sulsel Citra Indonesia Perseroda.
Thank you very much for generous sponsorship.
Now, before we go to the next session, we would like to see the branding video of Mechanical Engineering Department.
And a very warm welcome to the Department of Mechanical Engineering at Hasanuddin University, Indonesia. Standing as one of the oldest departments at UNHAS, the Department of Mechanical Engineering was first established on 10 September 1960. It has a long-standing history of providing quality education, with curriculum that offers a strong foundation for students to excel in their careers and ready to compete globally. This department has obtained the National Accreditation Status, Rank A, the highest based on the decision of the National Accreditation Board for Higher Education. With our new campus located at Goa, our students are allowed to have space, fresh air, and the feel of a beautiful atmosphere. The new campus is a wonderful learning environment with dedicated indoor and outdoor learning spaces. As well as technology development through the Center of Technology. There is still a love of learning in our students and encourage curiosity. Teaching and learning is at the very heart of what we do as a department. Our vision is to develop an excellent program in obtaining mechanical engineers that are capable in research, development of science, technology, and art on energy conversion, mechanical construction, and metallurgy. Our program comprises of 149 of semester credit points with duration of the program in 4 years or 8 semesters. A major part of our teaching and learning activities is focused on student-centered learning and laboratory-based education. With the help of total 30 highly qualified academic staff, the diverse range of teaching methods are used for different learning outcome and context, and none of the courses are acquired exclusively by one method. The learning process is also supported by total 11 well-equipped laboratories, a workshop arena, and 3 laboratories as research laboratories to support the final project. These laboratories support the fundamental theory taught in the classroom. Each laboratory is completed with practicum models, and at each practicum, standard operation procedure has also been established for each laboratory. Other than those laboratories, the department building is also equipped with comfortable classrooms. The department assistance room, which used for consulting assignment from lecturers to students. The Students Association room, for discussions and meetings between students. The department office, which used for consultation and assistance. And internet facilities to support academic interactions. Theaters and computer lab are also available at the faculty building. As a part of UNHAS, one of the largest autonomous university in Indonesia, of mechanical engineering can also access tremendous range of other facilities in the main campus. The facilities include libraries, university sports center, and university hospital. Finally, our department will continue to actively support mechanical development and innovation to meet numerous goals, including the needs of society.
Assalamualaikum warahmatullahi wabarakatuh. Selamat datang di Lab Camp Sensi.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. Introduce me. My name is Aswar Hayat. Today, I will hosting the keynote speaker. Allow me to introduce first keynote speaker is Professor SHUZI HAYASE from University of Electro-Communications, Tokyo, Japan. Prof. HAYASE, can you hear my voice?
Yes, sure.
Thank you
Can you
very
hear
much.
me?
So I want to introduce Professor HAYASE. Actually, he was my supervisor during my master and PhD in Japan. Today, I'm really happy he can join us in here as a keynote speaker. So Professor HAYASE got PhD from Osaka University and joining the postdoctoral in Washington University, and then as professor in Kyushu Institute of Technology, Japan, and then now join as professor in University of Electro-Communication, Japan. So today, Professor HAYASE will talk about perovskite solar scale. Time is yours, Sensei.
Okay. Can you hear me?
Yes, Sensei.
Okay. So thank you for the kind introduction. So first of all, I'd like to thank all of organizers to give me this opportunity of this presentation. My name is SHUZI HAYASE. Just a moment. SHUZI HAYASE in the University of Electro-Communications. My talk today is about the next generation solar cells, namely printable halide perovskite solar cell. So in addition, I'd like to touch on briefly the cylindrical solar cell research which was done in our laboratory. So my talk today is two topics, cylindrical solar cells and printable solar cells. First of all, I'd like to talk about cylindrical solar cells. This is a new one, briefly. So this is the cylindrical solar cells. This is a module, and this is the standalone cylindrical solar cell equipped with IoT sensors for agricultural use. This was done by the collaboration of Fujiko Corporation, CKD Corporation, and Ushio Inc. In Japan. So this shows the conventional solar cell structures. So in the center, the solar cell active, there is a solar cell active areas. So, this area is surrounded by encapsulators. So we are now focused on flexible solar cells. So in the active area, flexible photo energy conversion films is contained. And this flexible photo energy conversion film is encapsulated with two flexible plastic film. This is called flexible solar cells. And this flexible photo energy conversion film is encapsulated in cylindrical glasses. This is called cylindrical solar cells. So we are now focusing on this development of cylindrical solar cells. This shows the cylindrical solar cell itself. The length is 30, 60, 90, and 120 centimeters. And this is the one solar cells. And this is get together to make one module. The length is about 1 meter. This is a conventional solar cells. The length is about 15 to 20 centimeter, and this is also they get together to make 1 square meter. The advantage of the cylindrical solar cell over silicon flat solar cell is as follows. The module is much lighter compared to flat silicon solar cell. In this case, the weight is 12 to 6 kilogram per square meter, but cylindrical solar cell weight is about 4.2 kilogram per square centimeters. And durability to wind and snow is very high because wind passes through in the solar cells, and the mount is much lighter than the silicon solar cells because the wind process is less than this type of flat solar cell. So the mount is lighter here compared to this flat solar cells. Because of this, installation is very easy compared to this conventional flat silicon solar cells. And one of the most important advantage of this solar cell is that total electric power output in a day is higher than the conventional flat solar cells. This is 1.5 times higher than the flat solar cell, because in the case of flat solar cells, light comes from only from upside. However, in the case of cylindrical solar cell, light from all angles can be harvested. So this is because the total electric power output is higher. Okay. Now we are now making demonstration experiment outside like this. This is IoT sensor system equipped with cylindrical solar cells. Here you can see the cylindrical solar cell is there. And here the sensor system and communication system and rechargeable batteries are included. And the sensor system gives the data to receiver, and you can get the data in the computer or smartphone. In order to work the system, the electricity obtained from this cylindrical solar cell is used. So this is flexible module, cylindrical solar cells, and this is installed horizontally, or we can set this one vertically like this. So one of the expected installation area is the agricultural field. Now, the flat solar cell module is installed in this like this, but we want to replace this one to this cylindrical solar cell like this. And in the future, we want to change the landscape in Japan like this. Also, another application field is the building wall. Here, in Japan now, the wall is covered by design louver like this. And also you can see design louver like this. This is fashionable and less stress visually. So we want to replace this design louver with cylindrical solar cell, so we can get see-through and fashionable and visually friendly solar system can be installed. Also, you can see this the highway areas, and you can see this vertical louver. So also we can replace this one with cylindrical solar cells. By using the cylindrical solar cells, from the demand from the production site, we can get a perfect encapsulation with low cost and to give high stability. As demand from the user side, this gives high efficiency, high durability, and high weight, lightweight, flexible, and it's easy to install. And this is low cost, and perfect recycle is possible. Now, the output of this module is about this one, 80 watt. So right now, for active areas, flexible amorphous silicon is used, but we want to enhance this output to 240 watt, almost 3 times higher than this conventional one. So this is our target. So in order to achieve this target, we need to use perovskite solar cell. So I'd like to talk about this perovskite solar cell. What is all about perovskite solar cells? So anyway, lightweight and flexible photoelectric conversion films with high efficiency and high stability are needed. Now, this shows the solar cell efficiencies for various solar cells. Solar cell has 3 structures: N-type layer to collect electron, and light harvesting area, and P-type layer, which collect holes plus charge. And depending on the material of light harvesting layers, the solar cell is divided into these items. organic thin film solar cells and dye-sensitized solar cell and perovskite solar cell is a group of printable solar cells. And you can see amorphous silicon, cadmium telluride, CIGS. This is a kind of compound solar cells and multi-crystalline silicon solar cell and single crystalline solar cell. And the conventionally used silicon solar cell is this one, single crystal silicon, and the efficiency is 26.7%. So in order to get this single silicon solar single crystalline silicon, we need 1,500 degrees Celsius to get this crystalline silicon. But we are now focused on this perovskite solar cells. The efficiency goes up to now 25.5%. This is close to this conventional silicon crystalline solar cells. This is printable. So the process can be, process is coating and the temperature is low at about 100 degrees to 200 degrees Celsius. Even if the process temperature is so low, the efficiency now close to this single crystalline silicon solar cells. This is amazing, the result. So by the way, as the printable solar cells, the efficiency of organic thin film solar cell reach almost 18%. Here, the light harvesting material is organic polymer. So dye-sensitized solar cell consists of dyes in this light harvesting area, and efficiency now goes up to 12 to 13%. And as I said before, the efficiency of perovskite goes up to 25.5%. So what is the perovskite, halide perovskite solar cells? This is a structure, and generally this is expressed by this equation, AMX3. A means cation, organic cation. M means lead cation or tin cation. And X means I minus, Br minus, Cr minus, namely halide ions. So it seemed that the structure is complicated, but the synthesis of this compound is very easy. This is the starting material. So this material and this material is mixed. You can get this compound. Very easy. Just blend two materials. And this material and this materials are commercially available. So if when you can get this one and this one, just by blending, you can get this one very easy. And this is the formation of this one is just like the formation of Na plus Cl minus. Two cations is in the water, and when the water is evaporated, you can see NaCl salts. So the mechanism is also same. This one is in the solutions, and when the solution is evaporated, you can get this crystal. So single the unit of this crystal is this octahedron, in which this is halide, 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 and in the center, lead ion present. And this octahedron make the consecutively linked like this. And this iodine is occupied by 2 octahedron. And this is the characteristic of this perovskite, halide perovskite structures. So when this was linked like this, you can see the iodine I minus lead to plus, I minus lead plus. So this arrangement can be seen in this direction and in this direction. So this bonding is very important for realizing high efficiency of these solar cells. Now, the solar cell structure has 3 structures, as I mentioned before, but the thickness is about 20 nanometer to 100 nanometer and 200 nanometers, very thin layers. So we have 2 structures from light coming directions, N-type, lead perovskite, and P-type, or P-type, lead perovskite, N-type. You can take both structures. So, but right now, this is called inverted structure. This is called normal structures. And right now, this normal structure gives higher efficiency. So the preparation of this device is very easy. In the plastic sheet with transparent conductive layer, the P-type layer was spin coated and baked at 150 degrees Celsius. After that, the perovskite precursor is coated and baked at 100 degrees Celsius. And after that, the N-type is spin coated and baked at 100 degrees Celsius, or you can make this one by vacuum deposition method. Finally, the electrode is coated and you can make solar cell easy. As I said before, the fabrication is simply coated process, and the temperature is very low at around 100 degrees Celsius to 150 degrees Celsius. So because of this, you can make this layer on plastic sheet. So usually for making small area solar cells, spin coating process is used. But for the fabrication of large area, just like 1 square meter, the slit coater process is used. But anyway, both are coating process. So in order to get a higher efficiency of the solar cells, we have to control the crystal growth of perovskite at 100 degrees Celsius. If the perovskite crystal size is different like this, the surface is like this, and it's very difficult to grow the next layer on the perovskite. And sometimes small holes appear and short circuiting occur. So this is the not the perfect perovskite layers, and this is the expected perovskite layer like this. Surface is flat, and the grain is large like this. The reason of the high efficiency can be explained by the following items. One is that this has low exciton bind energy. This is almost same as that of silicon and CHAYASE, which is commercially available. On the contrary, in the case of organic polymers, the exciton binding energy is very large compared to this one. So in order to make charges, you need the energy. So energy loss occur in the organic solar cells. And also the perovskite solar cell is characterized by low defect densities, and this gives long carrier diffusion lengths reaching 1 micron, and this has small effective mass. Here, this is almost same as that of silicon solar cells and CHAYASE solar cells. So because of these properties, the perovskite solar cell has excellent performances for charge separation and charge collection. So this is why the perovskite solar cell gives high efficiencies. So I'll show you just one concrete explanation of the high efficiencies. So this is the mechanism for charge separation, P-type material, N-type material, and perovskite solar cells. So when the light is exposed to perovskite layers, electron is excited and shifted to the N-type, and the hole is shift to this P-type. But if there is the carrier traps, which was formed by lattice defect, the electron and hole is decombined here and disappears. This is one of the energy loss. So in the case of the perovskite solar cell, there are a lot of defect, vacancy, and substitution interstitials. I don't have enough time to explain this defect, but anyway, in the case of the lead perovskite solar cell, these deep traps disappears by some reactions, and this is why. So deep trap density is the responsible for charge recombination like this, and this trap disappeared, and the low disappears. So the trap density, deep trap density is become low. This is because the perovskite solar cells are called defect tolerance solar cells. So there is no defect in the lead perovskite solar cells. So, but the lead perovskite solar cell gave very high efficiencies, but we can expect much higher the efficiency by using the band gap of 1.3 and 1.2 electron volts. This is the relationship between the solar cell efficiency limit, theoretical limit, and band gap. So now the perovskite, lead perovskite is here, So we can get a higher, we can expect higher efficiency by using tin instead of lead. Also, the lead is poisonous and is not good for the environmental, but tin is less toxic. So the tin is now focused on. So this is why we're focused on this tin lead perovskite solar cells. So I'd like to skip this one. Now but the tin has a lot of the deep traps compared to the lead perovskite solar cells. So it was very difficult to enhance efficiency. But recently, the efficiency goes up gradually. At first, the efficiency is about 5%, and recently it goes up to 14 to 15% by decreasing the deep trap density. This is our result, and circles are results from other groups. Also, tin lead perovskite is interesting materials, and this goes up to now 23%. And also, at first, efficiency was low because this contained tin perovskite solar cells, which has a lot of deep traps. And by decreasing the deep traps, the efficiency goes up gradually, and this goes to 23%. Now, the next step is, this is the limit of the solar cell, 33%. Now, the people focus on developing 35 to 40% efficiency, which is beyond the Shockley Quasar limit. So in order to achieve this one, tandem cell is used. Tandem cell means is the combination of two cells. This harvest the shorter wavelength light, and this harvest longer wavelength light, such as IR region, and this is combined. So this is because we can get higher efficiencies. Now, for example, perovskite silicon tandem solar cells, 29.5% is was obtained by Oxford PV, and this shows a single crystalline solar cell, 26.7%. So by making tandem structures, so they can get almost 3% more to get higher efficiencies. Now, this is now becoming a major research target. So I'd like to conclude my presentation. So perovskite tandem is now one of the major research items, and tin lead and tin perovskite solar cell efficiency was low at first, but this goes up to more than to 20%. And in this case, the efficiency goes up to 15%. This can be expected much higher to 30% efficiencies. Thank you for your attention.
Thank you very much, Sensei.
Mm-hmm.
So before we go to question and answer, first I will let second keynote speaker to present his talk. After that, we go to question and answer session. For the second speaker, Professor TAWATCHAI CHARINPANITKUL from Chulalongkorn University. Professor, can you hear me?
Me? Who?
Not yet, Sensei. If Professor Tawatchai.
Yes, I'm on. But I wonder if there would be any comments or questions for Hayase Sensei.
Oh.
For me, I have no comments.
Okay.
But I'm ready for presentation.
Okay. Maybe we start question and answer, maybe 5 minutes before we go to the second presenter. So the audience, if you have question, you can raise your hand. So before that, waiting for the presenter, Sensei,
yep.
It's very interesting that now they are developing the tandem solar cell with silicon-based solar cell.
Mm-hmm.
So what about the stability of the perovskite solar cell? Is it improving much now so they can tandem with silicon-based solar cell?
Mm-hmm. Yes, this is a very good question. Now, previously, the stability of lead perovskite solar cell is not enough, but by adding some ions and by changing the composition and improve the crystallinity, the stability is now improved. So we are now testing the stability. Okay, and also in addition of the perovskite layer itself, stability itself, the encapsulation method is very important. But according to the paper from Oxford PV, the stability is enough for the commercializations right now. This is not my data, but this is a report from the, yes.
So now reaching 29, so the target is 35. So maybe what is the next step, Sensei, for achieving that 35, where we can improve? We improve the perovskite again, or the silicon? I think the silicon solar cell is already mature. I don't know. The progress is already maybe 20, 30 years back in around 20%. So what the researcher can do in that tandem or triple tandem, it's I feel can be achieved, or just silicon, I mean like a multi-junction, Sensei. Is it possible with perovskite?
Okay, so in order to achieve much higher efficiencies, as you mentioned just now, the multi-junction solar cell, 3-junction solar cell is expected, and there are some reports. Okay, but the efficiency is not so high right now. But the working principle is now proved already. Okay? The other research direction to improve the efficiency is that we have to decrease loss, energy conversion loss in the tandem cells. So we have to improve the contact between top cells and bottom cells. There are some losses between the contact between top cell and bottom cell. So we have to, anyway, improve these contact areas. Also in the tandem cells, light harvesting loss occurs. So we have to change the thickness or other items to decrease light harvesting loss, just like reflection and so on. So according to the experimental and theoretical data, 33 to 34% is now expecting
Wow.
Actually.
Wow.
So if this is achieved, we can put this one in the electric car. It's enough for collecting energy for electric car if the efficiency went up to 33%. So in Japan, the multi-junction solar cell, which is very now expensive, but in Japan we have 33% efficiency solar cells, and this is put on the car, electric car, and now test is now conducting. This is recommended by the Japanese government.
Okay.
And financially supported by the Japanese government.
Yes, thank you. From the presenter, Sensei, there's Dr. Hairul Arshad. Please, Dr. Hairul.
Thank you, Mr. Aswar Hayat. It is interesting to hear a presentation from Prof. I have a little question about defect, the percent of defect in Perovsky crystal, Professor. What the main source of the defect? Is it from maybe or from the raw material that make a defect that reduce efficiency of the crystal, and how to control it and to make sure that the defect is in tolerance area. Thank you for that answer, Professor.
In some part, I'm not hear you, but probably your question is about the defect.
Yes.
To decrease the defect, right?
Yes.
Okay. So in the case of lead perovskite materials, so the I minus defect is main. Defect means vacancy. Okay, I minus vacancy is the main cause for the weight loss and the energy loss. Okay, can you hear? Okay.
Yes.
Okay. And in order to decrease the defect of I minus, one is that the I minus defect can be converted to less, for example, become shallow traps, okay, by reacting just oxygen. So the material is exposed to air, the efficiency is enhanced. Okay, this is one approach. The other approach is to control the crystallinity. So at first, the precursor solution is in the solvent, and by spin coating, you have to grow the very good crystal during the process. So the temperature and other process is very important. Process condition is very important, and almost all paper which appears in previous report is about process development. When, for example, when the temperature is went up to 120, the efficiency enhanced, or some additive is added, so the crystallinity is improved, something like that. Yeah.
Thank you, Sensei.
Thank you very much, Sensei. I'm so sorry, time is limiting us.
Mhm.
So I will have to go to the next keynote speaker. Thank you very much
Thank
for
you.
your time.
Thank you.
Thank you, Sensei. So the next speaker is Professor TAWATCHAI CHARINPANITKUL from Department of Chemical Engineering, Chulalongkorn University. Professor TAWATCHAI graduate his doctoral degree in Tokyo University, masteral degree also in Tokyo University. So today he will talk about nanomaterial research. Professor TAWATCHAI, can you hear my voice?
Yes.
Thank you very much, Sensei. So time is yours.
Yes. Assalamualaikum. Good morning, all of our participants. It's my honor to be the keynote speaker of the first IC-EMAMM 2021. Yes, today, as our MC has kindly introduced, our talk is related to our ongoing research work, which we try to contribute of the carbonaceous nanomaterials to the biocircular green economies. This contribution is a collaboration among our team members, whose name has shown in this first slide. At the moment, in many countries, including Thailand, the effect of the COVID-19 pandemic has affected our countries. And in case of Thailand, the World Bank has estimated that the Thailand GDP will contract for 8.3% in year 2020. This is because of the COVID-19 has hindered and stopped many activities in our countries. And I do believe that this kind of effect would also took place in many countries. But anyway, as the chairman of the IC-EMAMM 2021 mentioned about the sustainable development goal, I also try to link my talk with our national policy in Thailand, which we call the bio-circular green economies. The bio is relevant to the uses of bio-renewable resources, and the circular economy is also has been adapted from many countries, including Japan. Since I was student in Japan, Japanese people, they are very keen in circulating their resources. They use their resources very effectively. But now in Thailand, we try to adapt such a scheme in our country as well. Reuse, recycle, this kind of circular economy. And the last, because of the announcement and promotions of the United Nations, we try to think of the sustainable productions and consumptions. If we refer to the SDG, Sustainable Development Goals of the United Nations, I would mention that our research attempts, our research activity would reply the 12 and 17 goals of the SDG. Here, when we raise about the emerging issue in Thailand, we also concerned about the global warming, the increase of populations, the decreased depletions of water resources or water pollutions. We talk about the waste disposals and depletions of the natural resources. That's why the government has announced the national policy of the BCG or biocircular green economies, which we try to use our strength. Thailand and Indonesia, we have many things in common. We can produce a lot of food and agricultural products, but well, we are trying to do our best. Many research team has tried to generate the research outcome for the medical and well-beingness of our people. In Chulalongkorn University, we also have a team who try to develop the vaccine that we can have the self-reliance to against the pandemic of the COVID-19. In our case, we try to develop the new knowledge and find the new data, understanding based on the sustainable technology with the focus on the carbonaceous materials. We try to make use of the renewable feedstock like biomass and try to generate the high value added products for the well-beingness of our people. As we listen to the Hayase Sensei lectures, solar energy is also one of a very important field because our people, we need energy, we need electricity. In such applications, from the viewpoint of material science, carbonaceous materials can also play an important role because we can use it as an electrode, as a dispersants, because such a carbonaceous materials, they possess many unique properties like the high thermal conductivity, good optical properties, excellent mechanical strength, and also extraordinary high electrical conductivities. This kind of promising properties can be applied in many applications. As I mentioned, the solar thermal fields, drug delivery, bioimaging, and so on. At the moment, we cannot deny that our countries still rely on the petroleum-based precursors. And now one of hot issue in Thailand is the increase of the petroleum price. So we try to find some other alternative precursor, as you can see in the picture on the right hand side. Some others biomass like glycerin, which is the byproduct of the biodiesel production. We turn the vegetable oil into the biodiesel, and 1 liter of the biodiesel, we also receive the same volume of the glycerin, which can be used for synthesizing or producing carbon nanoparticles. Or even some plant like the water hyacinth. Water hyacinth was not the authentic plant in Thailand. Our King Rama IX, about 100 years ago, he has received this water hyacinth as a present from Indonesia. That's why we call the name of this water hyacinth as Java plant. But at the moment, such a water hyacinth, they grow very fast and stuck in many rivers and cause many pollution problems. So we try to convert such a water hyacinth into the carbon material as well. And sometimes we also have a problem due to the industrial process. Our industrial colleagues have collaborated with us to make use of the waste petroleum oil, we call the slop oil, as a precursor for producing carbon materials. In the past, they just burned it out to get only energy, but now we can get both energy and high value added materials. This kind of industrial waste, I have to mention that lubrication oil, petrochemical waste oil, slop oil, or even waste ethanol. Sometimes in the fermentation and distillation of the ethanol, they also have some waste with some contaminations, or even the waste tire. We can use such kind of industrial waste to produce carbon nanotube, graphene oxide, or even activated carbon. And meanwhile, for the renewable resources, we try to focus on the eucalyptus oil, water hyacinth. Now we try to use the watermelon as the raw materials for producing biochar or even some other starch. This kind of promising material like carbon nanosphere, carbon nanotube, biochar, activated carbon, and so on can be produced with the technology which we have collaborate with many partners in Thailand and in other countries like Japan, Taiwan, Philippines, and also we are looking forward to have the collaboration with our Indonesian colleague. As one of example, I'm sorry, we try to use such a petroleum-based precursor like waste ethanol, benzene, toluene, cyclohexanes with some particulate catalyst using the chemical vapor deposition for producing carbon nanotube. And the cost reduction can be achieved by adjusting the ratio of the raw material to catalyst to control the temperature to find an optimal conditions to produce such a carbon nanotube with a much cheaper price. And we have reported such information in some published journals. For the actual applications, this is an example that we collaborate with our industrial partner. They have their waste, they have money, but they need know-how and know why. So we use our knowledge from the lab scale experiment to the bench scale for producing carbon nanotube from the waste. This is the fluidized bed and trickle bed in with the bench scale level. It can produce carbon nanotube 1 kilogram per day. It is still small anyway when we compare with other process in a commercial scale. But this is the collaborations between academic and the industrial, which we also recently have reported in the journal. With the collaborations of our colleagues from other countries like Professor Sano in Kyoto University, we try to develop the new technique with a very cheap investment. For example, we have a special design electrode, which can provide a cavity for the arc discharge, which we can use this kind of configurations of electrode for producing single wall carbon nanohorn. And from our side, we also try to replace the graphite lot by using the carbonized water hyacinth powder instead. So instead of using the high cost pure graphite lot, we can make use of the biomass to generate such a single wall carbon nanohorn as well. For the functionalization, this is to increase the value added or to increase the functions of our carbonaceous materials. We can use many kinds: covalent functionalization, non-covalent functionalization, or even with a surfactant. Today, one of my master students, Mr. Ritikiat, we also present to you that we try to use our carbon nanotube to mix with cement to increase its mechanical properties and to increase electrical conductivity, with the ultimate purpose that in the future, when we use more electrical vehicle, even the street can be used as the movable charging stations. If we can make the cement with a mixed with carbon nanomaterials, which can generate induction charging. To achieve such a functionalizations, we need a lot of characteristics based on many aspects of carbon materials. Just a moment, please. Then let me move to the applications of our carbon materials. At the moment, our research team has tried to contribute in many aspects. For example, development of new adsorbent, such as hybrid composite or heterogeneous catalyst, or even sensors. In this presentation, I would like to share some interesting result of our ongoing to you. For example, catalytic conversions of biomass into value-added chemicals. We need a heterogeneous catalyst that we can use our carbonaceous materials as a catalyst. We can convert glucose, fructose into other high value-added products like levulinic acid, furfural, and so on. Such a high value-added product can be used as food additive or the pharmaceutical applications. For the specific example, this is a collaboration with our colleague in the Philippines, Dr. Chulalongkorn in the University of Binadao was my previous postdoc fellows. She came to Thailand and collaborated with our team member. She tried to prepare the sulfonated graphene oxide and to use it as a heterogeneous catalyst for converting the petrochemical waste oil into other products. And then we can prove that we can convert the biomass which contain the cellulose, fructose, sucrose into the levulinic acid. And we just recently report this work in a catalysis today. Meanwhile, we also try to learn to explore the mechanism. This is also another work of my PhD student, which we reported in the Applied Surface Science 2 years ago. We can elucidate that such a nickel-doped carbon nanoparticles can convert methyl levulinate into the gamma valorolactone, which can be used as a medicine. This is a new applications as well. And as another recent work, one of my postdoc fellows from Vietnam, Dr. Yang, she also tried to adapt the work proposed by Dr. Lavakon from the Philippines to use the sulfonated magnetic carbon nanoparticles to convert the fructose to 5-HMF, which is also the high performance fuels. And in this case, instead of using the industrial waste, we try to use the eucalyptus oil. I believe that in Indonesia, there are also many eucalyptus trees because we can use it for the pulp and paper industries. And such a eucalyptus can produce such a eucalyptus oil just can be renewable resources. Then we also have a new work which we try to help contribute to the problem of the carbon dioxide or carbon footprint. We use such a nickel-doped carbon nanotube as the catalyst to convert the carbon dioxide from exhaust gas of industrial process for producing methane. We call carbon dioxide methanation. And we use this previous experience from using carbon nanotube as catalyst. Again, in this case, we use carbon nanotube that can be produced from eucalyptus oil and ferrocene and doped with nickel. And then we can convert carbon dioxide into methane with acceptable conversion efficiency of 38%. And yield of methane is as high as 33%. Of course, we still need more improvement. For the pollution problem, we try to use our carbon nanotube, which can exhibit the magnetic properties, because in our carbon nanotube, they contain the ion nanoparticle inside, so it can respond to the magnetic field. Once we can use such a magnetic carbon nanotube for absorption of the water pollutant, like in this case, we try with the methylene blue, reactive red 31, reactive black 5, and we can see that such a carbon nanomaterial can remove such a pollutant very fast. And additionally, it can be removed from the suspension by using a very cheap magnetic field. We need not to use the filtrations or centrifugal equipment, which is very expensive. And for the antibiotic, in many countries, like in Thailand, we have a lot of the farmer who try to produce shrimp or some water food resources, fish. Such in the shrimp farm, they use a lot of antibiotic, and such an antibiotic can be leaked to the natural resources. So some water resources has been polluted with such an antibiotic. So to remove such antibiotic is also one of our national problem. So we try to prove that such a metallic carbon nanoparticles, not just to remove such a dye or conventional pollutant, it can be used to remove such an antibiotic as well. And this is what I mentioned a little bit. And if you would be interested in this work, my colleagues, Dr. Litikiat Bandao, who is a master student, will present in more detail to you in the afternoon that we try to use the carbon nanotube with the cement composite in order to control the conductivity of the cementitious materials. And we have still many things to do. We still have the problem that we can increase the electrical conductivity, but on the other hand, the mechanical strength was hindered. So we have to find out the reason why the mechanical strength of the carbon nanotube cement composite become worse when compared to bare cement. This is also what we are trying to explore, and we look forward to collaborations from our colleague. Of course, if our Indonesian colleague would be interested in this kind of this work, please contact us. This is some previous data which my colleagues from the civil engineering has just recently published in the construction and building materials. This year, we try to use a microscopic analysis to analyze the dispersibility of carbon nanotube within the cement composite. In this work, instead of using only multi-wall carbon nanotube, the polypropylene fiber is also incorporated. Then please move to other applications. This is the carbon nanotube coated with ethyl cellulose. It can be used for the benzene detections. In Japan, it's quite difficult to imagine, but in Thailand, the drunken driver is also the problem. So we need to develop the alcohol sensor for using to be as a countermeasure to prevent, to protect accident from the drunken driver. So such a alcohol sensors, we can use this kind of carbon nanotube and detect is a response when compared with other sensing materials. This is also ongoing work which we try to contribute. As a real example, this is a collaboration, because I am from chemical engineering department, but as such a sensor, we do need the electrical engineering knowledge. So we have collaborations with our colleague from electrical engineering department, and we develop this kind of sensor set and test its performance. As we listen to the lectures of Hayase Sensei, that the dye-synthesized solar cell or solar cell application is also one of promising for human being, because we have abundant source of solar light in every day. Once we can convert the solar energy into electricity, we can help the problem of the depletion of the petroleum and other fuels. So in our work, in our group, we also, this is quite long times ago that we try to use nanotechnology by using the titanium titanate nanotube is from titanium. We make the hydrothermal treatment of titanium to generate the titanium nanotube and incorporate with the carbon nanotube, and then we use as a electrode materials for our dye-sensitized solar cells. And 10 years ago, we can prove that our dye-sensitized solar cell can achieve the photo conversion efficiency of 3.9%. And for other applications in the pharmaceutical field, we also try to talk with our colleague from pharmaceutical science department. This is the plasma modified carbon nanohorn for the slow release of PVPI, we call polyvinyl pyrrolidone iodine, that can be used for a disease of the lack of iodine. And we can show that our carbon nanohorn is help safe. It can be used with the without any undesirable effect to the mice. And then we try to use this kind of composite for the release of the iodine into the mice. I would be before schedule a little bit. This is the slide to conclude what I'm trying to share with you today, that utilization of biocircular resources, which include the industrial waste or biomass for producing carbon nanomaterials, pave an alternative way for the sustainable development with a better resource utilization and preservation for our society. I have shared with you that there are so many promising applications, such as heterogeneous catalysts, which can convert the biomass into other high value added chemicals, can be used for the wastewater treatment, can be used for the dye-sensitized solar cells, or even to improve the property of cement. This kind of research activities with the collaborations from our colleagues, not just in Thailand, but in many countries, can help us to achieve the sustainable development goal in the future. Of course, we still need further in-depth investigation, which we would like to call for the collaborations from our colleagues from Indonesia, from Japan, because we believe that the more we share, the more we gain. Last but not least, I would like to acknowledge the organizing committee of IC-EMAMM 2021 for the hardworking and the excellent arrangement of this conference. And all of my colleagues from Japan, from Korea, from Taiwan, and from other countries into the Philippines for their collaborations. Without their collaboration, we would not have such new data to share with you today. And last but not least, thank you for your attention. This would conclude my presentations. Any comments or questions would be welcome. Thank you very much.
Thank you very much, Professor TAWATCHAI. Very good presentation. So for the participant who like to their participant raise hand, please. You can directly ask Professor TAWATCHAI. Please, Mr. Arianto, you raise your hand, please.
I'm sorry, I could not hear your voice.
I think your mic is still mute, Mr. Arianto. We cannot hear your voice, Mr. Arianto.
Hello?
Yeah, we can hear you. Please.
Thank you. The presentation is very interesting. I, as a student, sometimes research to the state of producing crabs. In contrast to the two presenters, I see that research reaches the application. Suggestion for us so that the research can reach the application level. What should we do? The second, what are the steps to produce the best research? Thank you.
May I confirm your questions again? You have two questions to me, that right? The question is the level of the applications for the environmental pollution problem, right? Do you understand your questions correctly? I'm so sorry that I could not hear your voice clearly. Can you repeat your questions again, please? I'm so sorry. Maybe my connection is not so good. Please.
Suggestion for us so that the research can reach the application level. What should we do?
I see. Very good questions. The
second,
yes.
What are the steps to produce the best research? Thank you, sir.
Thank you very much. Yes, as I mentioned in my presentation, that to do the research, we need patience. We need the commitment. Though sometimes when we do research, we have so many obstacles. We still have many problems. But such a problem, one way to solve it is to have the sufficient communications with your colleague. In my team, I try to make discussion with my student or team members at least weekly, once a week. And we try to have this, for example, the in-official meeting with our colleagues, because we try to have the collaboration not just in Thailand, but in other countries. But because of the COVID pandemic, it's quite difficult for us to have the face-to-face meeting. As a new normal, we can have to use the online communication to share information. And to make the research to be applied in the actual life, we have to talk with the industrial or investor as well, because even we are national university, the budget for the research is still limited, and we are not so keen in the market research. So if you really want to make your research to be the real applications for your people, you have to talk with your industrial colleagues in a very, very frequent, and make them understand. And sometimes we have even to share some IP, intellectual property, with them. If you just keep your IP in university only, you do not open it, we cannot make it real commercializations. And then for your second questions, how to level up the research. Again, it would return to my first comment that the intimate or sufficient communications among your team colleagues is very crucial. And sometimes, even in Thailand, when we use Thai language, even we use the same language, but because of the generation, sometimes we misunderstood each other. I don't know whether the same problem in Indonesia or not. When I was student in Japan, I also experienced such a problem. Young generation and older generation, even they speak in the same language, but they use different meaning. So to make discussion, to have the intimate interactions, sometimes I try to do my best to spend my time with my students to do experiment, to do analysis, or even to observe their presentations directly. This attempt would also help to level up the research outcome. And more than that, I think the open collaborations. If you just talk with your team only, you do not open the window of the collaboration with other countries. In my team, I try to call the collaboration from the Philippines, from the Vietnam. In the past, we just collaborate with the Japan, but now we can become more open to the Korea, to the Taiwan, to the mainland China. This kind of open-minded would be very important for level up your research outcome. This is my personal experience.
Thank you very much for the answer, Sensei. So I have a question also, Sensei. So water hyacinth, we call it here Enceng Gondok, also actually a big problem. So which part in your research you convert into nanomaterial, which part of that water hyacinth actually? And then the second, I also working in DSSC during my master and my PhD under Professor HAYASE. So that TNT replacing the conventional anatacid titanium dioxide, also I think very good approach in order to enhance the efficiency of the DSSC. I want to know a little bit more about that, Professor TAWATCHAI.
Thank you very much for your questions. First, talking about water hyacinth. In fact, water hyacinth is also one of our national agenda. There are so many Thai researchers working on the water hyacinth. We can apply water hyacinth in many means. For example, now we need more the logistic because of online shopping. When you buy something from the internet, they need a cushion to protect your products. So instead of using the plastic cushion, some people they cut the water hyacinth into the chip and dry it. Yeah. And such even simple applications can make that company become the millionaire. They can use that water hyacinth as a cushion. Wow. Wow. But in our case, because we are the scientists and we are researchers, so we try to challenge to use more technology. So in my case, we convert the water hyacinth into the carbonaceous powder. It means we dry it in the sun, and then we carbonize it in reactors, and we turn it into the powder for producing the graphite lot. And we use such a graphite lot for producing carbon nanotube. This is a collaboration with our colleague from Kyoto University, who has developed, Professor Sano has developed this arc discharge in water. He even published this in Nature. And we try to adapt his technology by using our materials in Thailand. And I believe that this idea is also open. Even our Indonesian colleague want to use. Yes, I think water hyacinth is also very, very much abundant in Indonesia, in Java Island, and in many islands. So this idea would be very interesting and would open the window for our collaborations with Indonesian colleague. For your second question about the TNT, titanate nanotube, and carbon nanotube. This work is a little bit old, it's 10 years ago. So I believe that at the moment, the efficiency of dye-synthesized solar cell much improved. In that case, we believe we have some knowledge that the titanium is also the good semiconductor. But because of its morphology, it is a spherical. We wonder if we can convert into other form, which we can control the surface area and can be used as an entangling network with the carbon nanotube. So by accident, we discovered that by the hydrothermal treatment of spherical titanium, we can produce titanate nanotube. And because of the cylindrical morphology, once we incorporate with the carbon nanotube, they can entangle each other. So we can have more effective junctions, which can be used for I cannot remember the short circuit of electrons in the solar cell. That's why we can achieve the efficiency of 3.9%. But at the moment, I believe that maybe HAYASE Sensei team would have much more sophisticated solar cell research. which can provide a higher efficiency. Unfortunately, this work, one of my doctor student, after his graduations, he joined a company, but in his company, they do not focus on the solar cell application. So we couldn't continue this work, but some knowledge, some know-how is still remain.
Okay, one more question, Professor. About this eucalyptus, you convert CO2 into methane. This also quite interesting topic actually. We are here in here. You use eucalyptus oil only for like a herbal oil or something, but you can make it as like a converter from CO2, because we are in here we are mechanical engineer. We also facing that CO2 problem. If we can follow your path, doing your research like eucalyptus and then converting into methane, that I think that's very great. Can you tell me a little bit more about that?
Yes, of course. This is also very exciting work for me as well. This work, I have to give the credit to our young generation colleagues from the Philippines. 4 years ago, there are young teenagers from University of Santo Tomas from the Philippines coming to take internship in my lab. And they proposed that whether we can use many kind of biomass as a precursor for producing carbon nanoparticles. And among them, we found that eucalyptus oil, which normally can be used as aromatherapy, as you mentioned, in many countries. In my house, I use eucalyptus oil as aromatherapy. Of course, as aromatherapy, the value added is quite high, but we still find a new way. And we found that eucalyptus oil with the chemical vapor deposition technique with appropriate catalyst, we can generate carbon nanotube. In other conference, one of my master students, he will present to the audience that we can use the nickel nitrate as a catalyst, and also use the ferrocene as a catalyst for producing carbon nanotube from eucalyptus oil with acceptable conversion and purity. And then, as another step, maybe related to the previous questions from our previous participant, one of my colleagues from another university, in Mahidol University, he has knowledge based on his experience in Japan from Shizuoka University that he can convert carbon dioxide into the methane. And by accident, one of my master students, with co-working with him, has found that we can convert carbon dioxide using our carbon nanoparticles catalyst, and then we can generate methane and also another carbon nanotube as a byproduct. And if we make a fine tuning of the synthesizing conditions, we can get both methane and carbon nanotube from such a carbon dioxide. And now this work is still ongoing. My collaborator in Mahidol University, he also tried to explore more, and recently we have prepared a manuscript to publish in a journal, which we can share with you later on. Of course, if our Indonesian colleague would like to share with us about the eucalyptus oil utilization, you are very welcome.
Thank you very much, Professor. Very interesting topic, because if you with this research, we can like revolutionize automotive industry, because their problem is CO2. If you change it into methane, it means you can make it like as a fuel again. I think it's very the bright future for this theme of research. Thank you very much.
Exactly,
Professor
like kill two birds by one stone.
Yes, yes, Professor. Thank you very much for your time.
My honor.
To move to third our speakers.
Thank you very much.
Thank you. So our third speakers is Professor Noordin Muhammad Yusuf from UTM Malaysia. Professor Noordin, can you hear my voice?
Yes, very clearly. Can you hear me?
Yes, yes, professors. So Professor Noordin is from School of Mechanical Engineering, UTM, Malaysia. So time is yours, Professor.
Can you see my slides?
Yes, clearly, sir.
Okay, thank you very much, Mr. Chairman. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to my fellow keynote speakers, to all the organizing committee members, as well as to all participants. First and foremost, thank you very much for inviting me to share a bit of our manufacturing research activities at this conference. So thank you very much for the kind invitation. So again, I would like to congratulate the organizing committee for organizing this interesting conference, as well as important because energy, manufacture, advanced material, and mechatronics are actually very important areas to the advancement of the world. And if we look at the focus of this conference, they have actually focused on sustainable development goals. Okay, and the question asked is, how can we contribute towards those goals as mechanical engineers? So I think it's a very, very interesting theme, a very interesting topic for a conference. So again, congratulations to the organizing committee. Okay, my name is Noordin, and I'm from the School of Mechanical Engineering, Faculty of Engineering, UTM. And the names listed here are some of my colleagues in the team that is working with me. Dr. Hasrul Akmal Ngadiman, Dr. Muhammad Azlan, Suhaimi, as well as Professor Ani Idris from the School of Chemical and Energy Engineering. So they have been contributing in the research that I will be presenting shortly. So we have done research in several areas. So what we have done is to actually select some which is related to the sustainable development goals. Okay, before we start, just a brief introduction of UTM. This is some picture of UTM. The first picture on the left is actually our mosque, centrally located in front of our administration building. And this is in Johor, Johor Bahru. And the picture on the right, this is our city campus in Kuala Lumpur. Okay, so we initially started in Kuala Lumpur, and then subsequently we moved down to Johor Bahru. And the picture at the bottom, this shows the map of Malaysia, as well as part of Indonesia. So as you can see, Johor is actually on the south, next to Singapore, near to Batam. And Kuala Lumpur is in the middle of the peninsula, which is the capital of Malaysia. Currently, we have a new campus, a branch campus in between Johor Bahru and Kuala Lumpur, which is in Pagoh. Okay, however, this campus is mainly focused on research. Okay, and one more, just a bit about UTM. Previously, a lot of you may have been familiar with, for example, Faculty of Mechanical Engineering, Faculty of Civil Engineering, and these are all synonymous with UTM. However, recently we have merged because of synergy. Okay, we want to synergize
the various activities of the faculties. So we form the Faculty of Engineering. And below the Faculty of Engineering, we have the various schools. I see you at the Faculty of Engineering, University Hasanuddin, you have the department. So over there, we have various schools. So I'm actually from the School of Mechanical Engineering. Okay, so this is actually a picture that I've taken from the website, United Nations websites, which relates to the sustainable goals. And this is actually a very noble cause in trying to eradicate poverty and also to improve life of everyone and everywhere in the world. So this is something that ought to be supported. And in this, there are 17 goals as listed over there. And all of them have been adopted by the UN member states in 2015. And we are supposed to, achieve that. Okay, they have set out a 15-year plan to achieve this goal by 2030. So in my presentation, I will be focusing, okay, for example, on goal number 6, which relates to clean water and sanitation. In order to get clean water and sanitation, we need to ensure that we don't pollute. Then I will also focus on a bit on goal number 9, which relates to industry and innovation as well as infrastructure. And finally, goal number 12, okay, which talks about responsible consumption and production. So these are, some of the goals that the research that we have undertaken addresses some aspects of these goals. Okay, so how do we do it? The research that we have undertaken encompasses the first one, sustainable machining process. Okay, how to make the machining process more sustainable. And then we also look at sustainable product and process assessment. We also look at lean and integration of lean and sustainable manufacturing, as well as green, lean, and Six Sigma integration. And finally, we will also talk a bit about research done on tissue engineering. Okay, so these are the 3 main areas of research that will be focused on this presentation. Okay, sustainable machining process. Okay, this is actually, we have done a lot of work on turning. Okay, turning is basically a process that is involved in producing cylindrical parts. And we normally use a lathe machine to produce turn parts. And a lot of us are familiar with turning, okay, turning. So when in our area, when we say turning, we mean producing cylindrical parts in the unhardened form. Okay, in other words, we turn the material which is unhardened. Over there, a lot of work, turning can be done with flood cooling. Okay, can be mostly was done in flood cooling previously. And when we talk about sustainable machining, the use of flood cooling or coolant is not sustainable. Okay, because this will cause pollution. Okay, so therefore we look at turning dry, okay, without the use of coolant. Subsequently, and normally turning dry is not a problem nowadays. So then the need for turning of hardened materials. Okay, so that's where the term hard turning was coined. So this was actually initiated in way back in the year 2000. Okay, that was the work related to this sustainable machining process was initiated in the year 2000, where initially we start with dry turning, then we go into dry hard turning. Okay, hard turning, but performing it dry. And then subsequently, we went into minimum quantity lubrication. And then we look at different types of base fluid, vegetable oil, mineral oil, and subsequently, in order to improve further, we look at addition of nanoparticles, okay, nanoparticles. So I think this was presented by the second keynote speaker, the use of various types of nanoparticles. And here we have actually used 3 different types of nanoparticle as additives to the base fluids, and then used in minimum quantity lubrication. So the key word here is minimum. Okay, in other words, previously when we talk about flood cooling, the coolant or lubrication use is of large quantity. So here, when we talk about minimum quantity lubrication, here the use of coolant and lubricants are actually very minimal. It's in the mist form. So that way we can actually reduce the impact of pollution on the environment. So we will talk a bit about this. So here I actually show you when you talk about the machinability of whatever material involving the turning process, it involves machine, and there are various factors that can be varied. And of course, various types of material are there. And finally, we have different types of cutting tools that we can actually use. And in terms of the responses, okay, there are also many responses that we can actually use. Here we actually measure cutting forces, tool life, surface finish. Recently, my students also measured vibration. Okay, we want to actually reduce vibration, all in the idea of trying to reduce or increase the tool life, as well as to reduce the surface roughness values obtained. So what we actually then look at is, okay, let me, when we first started out in year 2000, we actually reviewed the literature, and turning is already an established process. But when we look at hardened steel, which is about 5262 HRC, there are actually a lot of cutting tools like ceramic, CBN, PCBN available. And a lot of work have been published in these areas. And if you talk about unhardened steel, there are carbides, cermets, or even high-speed steel available. And again, there are also a lot of material published in the area. However, there are also hardened steel, which are in the 43, 45, 48 HRC region. Okay, so these materials, if we were to use ceramics, there is actually no problems in cutting them. But what about the use of carbide? Can we use carbide? So no work have actually been published at that point of time to actually look at the turning of hardened steel within this range. So as you know, ceramics, as a ballpark figure, you are talking about one insert. Easily it can cost you about, in Malaysian ringgit, 300 to 400 Malaysian ringgit per insert. Whereas if you talk about carbides, you are talking about per insert about just 30 to 40 ringgit, which is almost 10 times the cost. So if we can successfully use carbide, okay, for hard turning within this range, then of course, we'll do a lot of savings. So that was actually our start. We started off looking at that, machining of hardened steel, 43 to 48 HRC, but using carbide cermets. So, this was our first papers that we actually published. This was in year 2001. This, when we first started off, we started with unhardened material, but dry. Okay, so this was actually part of my PhD work under the supervision of Professor Venkatesh. Then we started off with this. Then we had another paper which again talks about RSM application on the performance of coated carbide tools. So actually this initial work was actually to familiarize with the area, the technique, the machinability techniques. And surprisingly, this paper, initially we thought is actually a very simple paper, but the citations that it received, almost more than 500 citations in Scopus, and in Google Scholar, more than 700. So even though it's a very simple paper, but alhamdulillah, the number of citations that it received was actually very, very high. So then we went into hard turning. Okay, this is dry turning of tempered martensite. As you know, when you harden, you cool steel rapidly, you'll get martensite. So here, the martensite is tempered, so you get HRC was about 45 HRC, and we were able to use coated carbides and civet for that applications. So, this was from 2001, 2003, 2007, we actually continued doing research in this area. Okay, then upon graduating, I start supervising my own students. So this is where I started to look at minimum quantity lubrication. So the problem was when we use dry hard turning, the tool life is relatively short. So we need to increase it. So one way that we actually explore was the use of MQL. And here we use castor oil. And alhamdulillah, we were able to get increased tool life through the use of MQL. Okay, then recently, about 2 to 3 years ago, we look at MQL, but now we put in nanofluids. Okay, in other words, we included nanoparticle. Again, the intention was to actually improve the tool life further. So here we added nanoparticles. Here we have added gamma Fe203. And this work is done by Majid from Libya. So he actually looked at the use of this, and alhamdulillah, he has already set for his viva and passed, and in the process of making some corrections. So here we actually had, these are the work that he was done on 2 phases. We actually look at 2 different nanoparticles, and we use paraffin oil. The previous work by Handawi, they use castor oil. Okay, castor oil is basically a vegetable-based oil. So we decided to use castor oil because we want to avoid using vegetable-based oil, which may compete with the human consumption. So that's why we go for mineral-based oil. So that's where castor oil came into the picture. And we added the gamma Fe203. Gamma Fe203 was actually developed by my colleague, Professor Ani, in the chemical engineering, and she has used it in various applications, including many different applications successfully. So that's where we decided to also use it for this particular work. And here we also use 2 different nanoparticles, which is the gamma Fe203, and we also use graphene. So we actually compared the graphene's performance and the gamma F203. So this was done in phase 1. We actually compared just paraffin, then compare with paraffin with gamma Fe203, then paraffin with the gamma Fe203. Okay, so no, with the graphene. So we have three different combinations, and from the best one, we actually do a complete analysis where we look at different feed rates, different cutting speeds, and then develop various mathematical model. So apart from different nanoparticles, we also look at different concentration, loading, the loading. You have the 0, which is just paraffin. Then we have 0.4, 0.8, 1.2 for the gamma Fe2O3. And similarly for the graphite, we actually did this. So this is all based on medium conditions. And then from here, we select the best, and then we continue to phase 2. Okay, so this is the setup for the material. So this is our CNC machining turning center. And we have actually a tool dynamometer here to actually measure the cutting forces. So this is new. Previously, we had to use we had to fix our dyno on a conventional machine, and that creates a lot of problems. So we recently have the CNC turning center, and then we purchased this dynamometer, which can be fitted onto the tool turret so that we can measure the cutting forces simultaneously. Okay, so these are some of the publications produced by Dr. Said. Okay, so normally I get my students to do a review. We do a review on MQL using paraffin-based nanofluids, so that from here we can actually, look at how we can be, focus on something which is different from what have been focused by other researchers. Okay, so then we have another work that was done on how we can actually determine energy consumption. Very important for us to determine energy consumption, because if we know the energy consumption, then based on that, we would be able to, determine conditions that would result in minimum consumption of energy. So this was a recent publication and by Dr. Rosdi. Dr. Rosdi is also in Makassar, okay, I think neighboring to University Hasanuddin, and Dr. Rosdi previously was did his PhD under my supervision previously. Okay, then went to the next thing we have done. We look at sustainable product and process assessment. So this is actually, we use weighted fuzzy. Okay, again, the whole idea is actually to assess the sustainability of a particular product, because when you talk about sustainability, there are actually 3 pillars. Okay, so we need to look from the 3 pillars point of view, assess it. So if you have an existing design, you can roughly determine the sustainability score. Then you do improvement to your design. Then you'll get a new sustainability score. So in that manner, you can actually use this approach to assess product design. Okay, so this was actually a paper work done by my student, Dr. Pezman, way back in 2012, where he actually came up with this approach to product sustainability assessment. Again, the whole idea is to make the product more sustainable, okay, when assessed from different perspectives. This is another paper work that we have done, where we actually measure the warehouse, where we look at warehouse management system. We identify various indicators and then use these to actually assess how sustainable the warehouse management system is. So this was done by my student, Dr. Ehsan. This was recently published last year, 2020, in Cleaner Production. So, this was a work done where we tried to integrate lean and what you call it, Six Sigma. Okay, so what we did is, we integrate lean and sustainable manufacturing. Okay, so when you talk about sustainable manufacturing, the focus is, there are certain aspects that we are focusing on. And when you talk about lean, the focus is actually on waste reduction. So, so what we attempted to do was try to integrate that. Okay, so what we do is we integrate and we use value stream mapping. So value stream mapping is actually a very common tool used in lean in order to identify value-added and non-value-added activities. So what we did is we actually use VSM, and then we integrate, in other words, our axis instead of what you call it, the value-added and non-value-added, our y-axis is actually sustainability. Okay, so this was actually work done. I think this Dr. Nitya also graduated recently. So this was when he first started off in 2015. Okay, and this is the recent work. Current student, engineer Tiru, he is actually a manager in Dyson in Senai, which is close to UTM. So he was working on trying to integrate green, lean, and Six Sigma. I think everyone is familiar with Six Sigma. I think the focus of Six Sigma is actually on variability reduction. You want to reduce variability. I think if you reduce variability, quality will go up. And the focus of lean is also people quite familiar, waste reduction. You want to reduce waste. Green is actually more on the environment. We want to focus more on the environment. So basically what we attempted to do, traditional manufacturing, you have pre-manufacture, you get the raw materials, then you manufacture. Then after that you use, when the customer buys the product, you use the product. Finally, you goes to landfill. Okay, so this is traditional manufacturing, and this is need to be improved, because otherwise the whole world will actually full with waste products. So that's where lean comes into the picture, where in lean we attempt to reduce. Okay, so by reducing, then we can actually, instead of taking something completely fill up in half 10 years, now we can extend. Okay, because we reduce the product, waste product. Then we go into green manufacturing. So under green, we try to reduce it even further, whereby we reuse, we recycle. So Six Sigma, everyone is familiar, variability reduction. So a lot of work have been done in integrating green and lean. Okay, green, lean, Six Sigma. So what Tiru attempts to do is trying to integrate all three: green, Six Sigma, lean. There are some publications that started. Research in this area has also started. However, its practical implementation is still very little. So that is what our research attempts to do. So what we attempt to do was we try to analyze the enabling factors, which looks at green, lean, and Six Sigma implementation. So this again is a review paper that we produced, and we have actually submitted and currently under review. Okay, so finally, I hope I have time. I just go very quickly now. We have done some work on tissue engineering. So for those of you who have broken a bone, more often than not, what we do is to mend a broken bone, we normally have implants being we have to go to an operation where we actually use for example implants, and subsequently for example you need to have plates to hold the broken bones, and when the bone heals, then you need to do another operation, and then to remove the plates, for example. So what tissue engineering is all about is trying to avoid that. Okay, we try to avoid the second operation, whereby here we use scaffolds. We use scaffold. So these scaffolds are actually biodegradable. So the whole idea is the broken bones are being held by this scaffold, and this scaffold is biodegradable in the sense that over time they will degrade by itself. Okay, and in that manner we don't have to, when the bone is sufficiently healed, by the same time the scaffold would have already degraded and will be removed from the body in the normal way, in the natural way. So in this manner we can actually avoid a second operation. So our work on tissue engineering is trying to develop different types of scaffold to enable the healing of the bone naturally. Yeah? So again, this started off with producing nanofibers. Okay, nanofibers, and we use the electro-spinning process. Okay, so electro-spinning is very popularly used to produce nanofibers. And in our nanofibers, again, we use the gamma Fe2O3 produced by our colleague, and we integrate it with our the polymer material, which is PVA. Okay, so this was work done in 2014, where we started our first initial papers on nanofibers, tissue engineering. Then subsequently, in the previous work, we actually focused on diameter. The whole idea is by reducing the diameter of the nanofiber, we are able to increase the strength of the nanofibers. Because remember, what we are trying to do is we want to use the scaffold, and this scaffold need to be porous, and it need to have sufficient strength. So our focus in this initial work was strength. Okay, so through this experiment, we are able to identify that by reducing the diameter, we are able to increase the strength of the fibers. Then Dr. Hasrul, he continued on where he actually looked at how to ensure that the nanofibers are also porous. Okay, the scaffold that produced need to be porous. So here we now try to optimize two things, the strength as well as the porosity. So this was actually work that was published in 2016. And then we actually, and this is actually the process. This is the, what you call it, spinning process. You have the rotating drum and then the fibers. So you have, and this is magnetic because gamma Fe2O3 it has a very special properties where it is actually magnetic. So this illustrates the fact. And this is how the nanoparticles was actually produced using the co-precipitation method. And this was done by my colleague from the chemical engineering department. And this was the factors that we investigated. So we investigated 5 factors. This is a screening experiment trying to, because this is new. This process is new to us. So we need to characterize the process to identify the significant factors. And from our experiments, we look at 2 different responses, which is the what you call it, the Young's modulus as well as the porosity. Okay, so I don't want to go into detail. So this is your ANOVA, and we were able to identify the significant factors. And here we can see that the curvature is actually significant. And then this is the same data, only including the significant factors. And finally, we actually did a CCD, central composite design, whereby we want to get a second order model. So here we are able to get a second order model, where as you can see, there is a squared here, square term. And as you can see, when we look at the contour plot, we can see that in order to increase your Young's modulus, we can actually increase it further. Okay, we can actually increase it further. So what we did, we do a pass of steepest ascent to actually identify the maximum condition that can produce the maximum Young's modulus. Okay, so this has been identified, and we did the central composite design. And this is the ANOVA. And finally, as you can see, now we can see the peak. Okay, so this is actually, we are now at the optimum region, and this is the optimal condition that will be able to produce optimal values of Young's modulus. Okay, and we perform confirmation experiments to confirm the results. And this is repeated for porosity. Okay, same thing repeated for porosity. And again, we do a central composite design. And again, we get the peak maximum porosity. Why porosity is very important? Because we want the cell, the bone cell, to actually grow through the scaffolds, through the scaffolds. Again, the confirmation runs done. Okay, so this is what we did was we then continued where we actually produced 3D scaffold. The previous scaffolds were 2D. They are in the form of a mat. So, if you want to go to bone scaffold, then it needs to be in 3 dimensions. So we produce a work that we combine electrospinning, 3D printing, and tips to produce 3D scaffolds. And this is the current work that is done by one of our PhD students, whereby we want to increase further the strength of the scaffold. As you can see in the previous slide, the scaffolds that we produce are in the megapascal region. We need to go into the the gigapascal region. Okay, so we use the PMMA, and these are some of the possible materials. And here, what we attempt to do is we are trying to add nanocellulose. Okay, from literature, we are able to find, we actually established that the addition of nanocellulose can actually increase the strength. Okay, so this was actually some of the work that was actually reviewed by our student. And here, this is the fabrication method. Basically, we will use the 3D printing to actually produce the scaffold. And here we are going to use the DLP process. And this is the expected outcome, we hope to actually achieve. And this is currently ongoing. Hopefully this will be successful in producing the desired outcome. And again, this is a review paper that was published, accepted, where we actually look at nanocrystalline cellulose in bone tissue engineering application. Okay, so I think that's it. My apologies for the, if I've exceeded the time slightly. So again, I would like to thank the organizing committee for inviting me to present some of the research work undertaken by me and my team at the School of Mechanical Engineering. So hopefully this can, we are open to collaboration to anyone who is willing to collaborate. We have collaboration with various universities in Indonesia through our former students and our colleagues over there. So anyone who is working in this area, please feel free to contact us, in order to collaborate in the future. So thank you very much for your attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Noordin, for your presentation. This is very interesting for us because we are same from mechanical engineering department. We also did some same with your work. We are try dry turning, wet turning. One of my group also presenting today about that effect. In here, we are using just software to analyze the quality, especially surface roughness of turned materials. We use Taguchi method or ANOVA to get the optimum parameters. In your presentation, Professor, you also say you did some kind of mathematical model to predict the parameter for like turning. Can you explain to us more detail about what kind of mathematical model you use for that research?
Okay, thank you very much for the question. What we did was in our experiment, we used classical DOE. Okay, classical DOE. So basically, it's a 2-level factorial design. So it's, for example, 2 to the power, like the previous example we showed you on the tissue engineering. The same method is actually applied for turning, where we use 2 various factorial, 2-level factorial design. And we normally do it single replicate, okay, because the number of factors is a lot, so we do single replicate, but we include center points in our design. So when we insert center points, then the center points will replicate. So we use the replication of the center points to give us an indication of the pure error. Okay. Then based on this, we are able to determine the model. So this is what we call the mathematical model involving the significant terms as well as terms supporting the hierarchy. Okay. If the curvature is significant, I think this is where I think a lot of people don't include center points. They just do factorial. So how do you know that that is optimal? So I think this is where curvature is very important, because when you do two-level factorial, you are assuming linear relationship. When in actual fact, it's possible that it is quadratic. You have a quadratic equation. So if the curvature is significant, that's where we actually augment additional experiment, where we actually get the central composite design. So this way we can get a second order model. So like you can see in the figures that I presentation, we actually showed the peak. So that indicates that that is actually the optimal that you can get. So this is something that we have followed through in various areas of our research. In turning, in tissue engineering, we do the same thing. And alhamdulillah, papers are accepted because I think probably because of the rigor that we show, because we do confirmation run. So in that manner, that's how we actually get the model. I am more than willing to actually share with you and your students in the future. Do contact me. We can do a short course on this. How to go.
Yes, I think it's very important for mechanical engineering students to do this kind of detailed analysis, because sometimes they just do the experiment, that after that they cannot analyze the data, which one is more contribute to the effect of their
no problems. Just contact, we'll find a suitable time and we will be able to do it, inshallah.
Thank you very much, Professor. And here one more question for me. So you use in here lean manufacturing, green manufacturing. In your research, have you ever tried to recycle that cooling fluid used in that machining process?
Okay, very interesting question. Okay, I'll be very honest with you. This is actually what current research that I'm doing by one of my other PhD students, which I didn't mention. Okay, okay. First, let me answer to you. The cooling fluids that we use, previously we did dry, okay, dry. So no cooling fluids. Then subsequently we do MQL. Okay, so MQL basically there is almost no residue. Okay, but now the student that is currently doing the research is we are trying to use oil palm cooking oil, where we recycle and then use it as a base fluid. Okay, and then from there use it for MQL application. So we want to see, can we recycle oil palm, which is abundant because people cook, and otherwise this can, now there are some work done to collect cooking oil, but they are used in biodiesel production. Yes. So we are looking at, but there are not many. So if we can actually increase the usage of this spent cooking oil, and then refine it, recycle it, and then prove that it can be used again for example, machining applications. So this is what we are doing now. So pray to us that we are successful in this work. Inshallah, 1 or 2 years from now, we'll get publication in this area. Inshallah.
Inshallah. Thank you very much, Professor Noordin. I hope next time we can make a guest lecture or something, so we can in depth know about your research. Thank you very much for your time. So due to time limitation also I have to move to fourth keynote speaker.
Okay, thank you very much.
Thank you very much. So the fourth keynote speaker is Professor Bondan Tiara Sofyan. So Prof. Bondan is finishing her PhD in Monash University in 2003. Now, research interest is physical metrology, light alloy, defense materials, non-ferrous alloy, heat treatment, metal matrix composite. So due to time, time is yours, Professor.
Okay, thank you, moderators. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi.
Baik, my voice is clearly.
Yes, we can clearly.
Yeah, great. Yeah. A very good afternoon, a very good morning to everybody. Alhamdulillah, thanks to God that give us health, and we can meet in this prestigious conference. First of all, I would like to thank the organizing committee who has invited me to speak in this prestigious conference. And as have been mentioned before by Professor Noordin, the topic on manufacturing, energy, advanced materials, and mechatronics is a very important topic for now. I congratulate Mechanical Engineering Department, Universitas Hasanuddin, for organizing this conference. My topic today will be on enhancing Indonesia defense industry. So if previously Professor Noordin talked about topics and have shown us many impressive publications in many prestigious journals, what I will be presenting is something is different, because defense industry is something which is restricted and classified, so we cannot make publication through this area. So please let me share my presentation. Is my presentation can be seen?
Yes, Professor, we can see.
Yeah. Okay. Okay. Good. It is in slideshow now.
Yes, in slideshow now.
Great. Yeah. Thank you, moderators. Yeah. So once again, this is my topic, enhancing Indonesia defense industry. So my name is Bondan Tiara. So this is my Instagram account. Now I'm at Lemhanas RI, National Resilience Institute of the Republic of Indonesia. So this is the outline of my talk. First, I will talk about the law and the regulations for the as the introductions, and the second about the defense industry policy, and the third about the current status of the Indonesia defense industry, and will be closed with a summary. So for the introduction, the legal basis, because the defense industry, as I have mentioned before, is something unique, because it is a restricted industry. And the information in the defense industry is classified one. So this industry is actually heavily regulated by the government, because the government is the sole buyer, the only buyer of the product. Yeah, so it controls this industry. So the first legal basis for the defense industry is Law number 16, year 2012 on defense industry. In this law, it is defined that the defense industry is a national industry consisting of state-owned companies and private-owned companies that determined by the government to partially or wholly produce defense and security equipment, maintenance services to meet strategic interests in the field of defense and security located in the Republic of Indonesia. And the regulations of defense industry, the fact that the defense industry is heavily regulated is not only in the case of Indonesia, but if you see in all countries, the defense industry are heavily regulated by the government. This law number 16/2012, is revised through Undang-Undang Cipta Kerja, law number 11/2020. The main thing that is revised by Undang-Undang Cipta Kerja is on the lead integrators. In this undang-undang, in this law, there are now both BUMN, the state-owned companies, and BUMS, the private-owned companies, both may involve in all levels of defense industries, including as the lead integrators in the construction of defense equipment. There are 4 tiers of defense industry. The first is the lead integrators, and then the main constructors, and the part constructors, and then the tier number 4 is the materials producers. Previously, for the lead integrators, it is only the state-owned company who can play in that area. But through Undang-Undang Cipta Kerja, this is now open that both a private and state-owned company can be the lead integrators. The second main legal basis is the decree of head of KKIP, Komite Kebijakan Industri Pertahanan, number 7/2014 on the National Defense Industry Program. In this decree, there are they state 7 main program to develop in the defense industry. And the third legal basis is Government Decree number 141 year 2015 on the management of defense industry. Through this set of regulations, the directions of defense industry is as follows. As you can see in the slide, there are some strategies, and 3 of them are mentioned here. In clause number 43, to strengthen the defense industry, it is conducted through implementation of counter trade, local content, and offset in the procurement of weaponry from overseas. So each procurement of weaponry from overseas must be accompanied by counter trade, local content, and offsets. Through clause number 448, to strengthen the technology owned by the defense industry, it is conducted in the form of joint development with overseas part, joint development, joint production, and also joint ventures. And the last, for the research and development, through the clause 28 to 31, the technology strengthening for the defense industry is conducted through a research and development program, which is conducted by the elements of R&D institutions. It is the institution and also universities, the users itself, and the industries on the main equipment coordinated by KKIP. And what we have seen now for the counter trade and LCO, it has been conducted for the development of radar as well as the development of missiles. And for the joint development, it has been conducted in the development of aircraft fighter with Korea and the medium tank with Turkey. For the joint ventures, it is conducted for propellant. Now we are still analyzing which country is the best as our counterpart. And for the joint production, it is conducted for submarine production. We work together with Korea. And for the consortium, it is conducted to develop the rocket. This is the R122, R122B, Erhan 122B. And the goals of this directive is to make the defense industry professional, effective, efficient, integrated, and innovative, and to be independent in the military equipment fulfillment, and to improve ability in production of military equipment and maintenance services. And if we see the stakeholders of the defense industry, there are 3 main stakeholders. The first is the government, as I mentioned. The government is the regulator as well as the sole buyer, membeli satu-satunya. The second is the user itself, the military, TNI, and the police, the Polri, and other ministries, and the defense industry itself. The role of the government is to plan the fulfilling military equipment needs. The government also make the defense industry development planning. determine the military equipment technology that will be developed in the country, defense industry development, assistance and facilitation, provide the funding, control and supervision of the technology, promotions, control and supervision of the products technology, and preparing the human resources. The users, of course, their role is to use the equipment that has been made in the country, and preparing the human resources to master, to use the defense technology, and to do in country for all the maintenance and repair of their equipment, and to assist and to evaluate in the product and process and development to make all the products combat proven. And the defense industry itself, their role is to increase their capability in the production of military equipment, to prepare human resources, to keep the confidentiality for formulation of strategic military equipment and design, and to provide budget for research and development. Through the decree of head of KKIP number 7/2014, there are 7 national program that is as the focus of the defense industry. The determination of this 7 program is based on these things. The first is the strategic values, the high technology, the long-term use, the economic feasibility aspect, the possibility of transfer of technology, cross-government cooperation, and cross-ministries and institution cooperations. The 7 national program is the submarine, the fighter, the medium tank, the rocket, the missiles, the radar, and the propellant. And there are 3 additional priority through Perpres number 8/2021. There are the UAV Malay, the underwater sensors, and the military satellite. And now we are looking at the defense industry policy that has been in place at the moment. There are 6 main policies. The first is the implementation of LCO, the local content and offset, the international cooperations, the defense industry promotions, the licensing of defense industries and blasting enterprises, production of first articles, and the national priority program, the 7+3 ones that I have mentioned before. For the LCO implementation, this is as part of the procurement of defense equipment from overseas. As you can see here, it is started in 2015, and up to now there are already 33 package of LCO and TOT implementation with the value of 44.6 trillion rupiah. And the beneficiaries of this program, it is the state-owned enterprise, as well as the private enterprise, and most of them is the combinations of state-owned and private enterprises. In 2021, as you may know, 1 contract just signed. It is for the procurement of A400M, and the LCO packet already in discuss, but not been implemented yet. The second is for the international cooperations. So at the governmental level, it is called as DCA, the Defense Cooperation Agreement, and it must be ratified by DPR. And under that, then we make a specific cooperation for each articles that we want to work with. So there are several international cooperation specific for defense industry that has been signed between the countries. Most of them are either bilateral cooperation or with industry, with specific industry. The last one that we signed is the MOU on logistics between Indonesia and the Philippines. This is to cover the procurement of medium tank Harimau by the Philippines. The third is the promotion of defense industry. So Indonesia takes part in expos in overseas regularly each year. So we take part in the Korean expos, in the Philippines, in the Thailand, in the Turkey, in Dubai as well. But however, because of the pandemic in 2020 as well as 2021, the program is on hold because the budget is reallocated for COVID-19. We ourselves, we conduct Indo Defense as the expo and forum held by Indonesian government. The last one, it was conducted in 2018, which is where 60 countries participated in the Indo Defense. In 2020, the program is on hold because of the COVID-19 pandemic, and we hope that next year, on the 2nd to the 5th of November 2020, the Indo Defense 2022 will be held again. For the licensing of defense industry and blasting enterprises, the main or the general policy is to promote the local products. If the products are available in the country or it is a domestic product, we have to use that, and we are restricting imported products. Altogether, there are 138 defense industry, consist of 8 state-owned companies, and the rest are private companies. And for the blasting enterprise, there are 11 companies, 2 state-owned and 9 private companies. And we also produce first articles. Altogether, there are 33 first articles that has been produced. For example, here, this is the Swan boat. Yeah, it is produced by PT Mega Perkasa, and now it has been in the use of Navy and as well as the Army. And this is the first article of identification friend of foe, which is installed in KRI Oswald Siahaan 354, produced by PT Land Industry. And this is the status of the 7 national priority program for the jet fighters, still in the renegotiation process. For the radar, we still we are doing the technology audit. For the missiles, yeah, now we are producing already some of the subsystem in the prototype, and for the propellant, it is still in the feasibility. Now, so that's the medium tank. The next one of which we are very proud of is the submarine. So 3 submarines are already delivered to the Navy, the Nagapasa, the Arda Dedali, and the Alugoro submarines. And now PT PAL is in the progress of intermediate maintenance of KRI Nagapasa. And the last is the yeah, so that's the rocket, yeah. So we are proud of it. Erhan 122B, it can reach up to 28 kilometers, yeah. And now it is in the stage of mass production through national loan, domestic loan, PDN, pinjaman dalam negeri, domestic loan. And for the current status of Indonesia defense industry, as you can see here, it is assessed by Bappenas. It is the assessment result that for the ANOA, the infantry tank, it has reached the highest MRL 10, for full rate production. For the medium tank Harimau, it is MRL 9, low rate initial production. For the CN295, it is MRL 9. LPD, landing platform dock by PT PAL, it is MRL 9. Submarine, MRL 7, yeah. For the KFX, it is TRL4 MRL7. For the rocket, TRL7. Propellant TRL4, we already have some lab scale demonstrations, productions. UAV TRL3, it's already proof of concept. We hope that next year it will be the first flight. For PKR, frigate TRL3. For the Rudal, TRL 3, the missile, and for the intercept radar is TRL-1. One thing about, because this is IC-EMAMM, yeah, which involve universities, the involvement of universities and research institute is very important because we need to innovate. Innovation is a must to keep the state of the art of the products, and to innovate, it needs universities and research institute. However, most of the defense research is classified, so we cannot publish, yeah, or limited publication. So we have to talk about this because, as you can see, the medium tank now is already in mass production. The rocket is also in mass production, but no publication at all in regard with the two products. Similarly with the submarine. So as the summary, we see that the policy initiative to develop Indonesia defense industry, there are 6 main policies. The first is registration of defense industry, offset and local content policy implementation, international cooperation under the DCA, promotions, production of first articles, and 7+3 national priority program. Law number 16/2012 and its revisions in law number 11 year 2020 is to boost the development of Indonesia defense industry. And of course, involvement of universities and research institute is required to keep the industry's innovations, but we have to find how to make it happen in regard with the classified and restricted publication that can be produced through this collaboration. I think that's all, and I'm open for discussion about this topic. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Professor Bondan, for your presentation. Actually, it's very unfortunate you cannot write this result in a publication due to the restriction of the industry of defense. So in here also, Professor, we are already start a little bit under your former doctoral student with Dr. Shahid. Last time we produced a prototype for bulletproof vest using carbon fiber. We successfully passed the ballistics test for the first time. So
great.
But actually, for us in university, actually, if you want to enter that 7 priority of defense program in the Ministry of Defense, actually a little bit difficult for us. So there's any tips how we start? Because maybe a few years back we tried to like robotics for defusing bombs. That kind of robotic also we made maybe 10 years ago. But it's stopped. Maybe that's the problem. If we have a contract with military and then we cannot publish anything, we just working to make the prototype or the production. There's any tips for us if we want to join that this kind of research area, where we start, and then accept that the publication problems. Is it we need to like have a sophisticated manufacturing process in our campus in order to join this kind of research, or just like as academician we have the idea, based on this idea we can propose, or can you tell us about a little bit more detail about this?
Okay, yeah. So mohon maaf Pak Moderator, siapa ya namanya?
Azwar.
Pak Aswar. Okay, Pak Aswar, thank you for the comment and for the question. So one thing about the defense product, the first thing that must be done by university is to collaborate with the industry, because what is regulated by the government is the industry, as I mentioned before, and you see in law number 16, the regulation is on the defense industry, because we cannot regulate the universities. Yeah. We cannot regulate the universities. So for the product, because at the end of the day, the product must be a mass production things. Otherwise, if it is not certified, then the military cannot use it, because it is something universal all over the world. So the first thing to do is a university must collaborate with the industry, and the industry then got assignment from the government, yeah, because the assignment from the government goes to the defense industry. The industry, as I have mentioned, the industry is not all industry. There are only 138 industry at the moment, but of course the number will be increasing because we keep certify industry, because there are regulation how for industry to get certifications. The certification is first is the registration, yeah, the registration, then after that certifications. For universities, please work together with the industries, and then we can pursue. I have tried several times to involve in universities in this case, yeah, but then when it comes to publication, then the universities then step back, you know, because they need publication. So that's the thing. For the budget, it is available because the government provide the budget for the research, yeah, but we cannot publish, that's all. So I think we have to find a formula, yeah, how to overcome this problem, because as I see in riset prioritas, ya, DRN, Dewan Riset Nasional, there are the sectors for defense and security sectors, and there are a lot of research, yeah, but we have looked at that none of this, almost none of this research is come into mass productions, yeah, because it is not conducted with in collaboration with defense industries.
Bondan? Okay.
Yeah.
My second question, I'm really curious about that submarines. You say we have already product 4 type of submarines, but with Korea, I think, yeah. Three with Korea as a partner, I think.
Yep.
So in order to make this submarine, there is, after we collaborate with a Korean company or Korean institution, for example, there's any like transfer knowledge from Korea to Indonesia after we collaborate like that, or just like after we made that it's
no,
or there is like a knowledge transfer, or
yes, because there are 3 submarines in the contract. The first submarine was made in Korea, and some workers, engineers from PT PAL went to Korea to learn, and then the government also provide the budget for the transfer of technology. That's for the related course for the team that went to Korea. For the second submarine, then PT PAL take parts in the productions, but in Korea. And for the third submarine, the joining process of the submarines is conducted in PT PAL already. And we know that government has put some capital, PMN, penanaman modal negara, for quite a big amount to PT PAL to prepare them for the production facility. So they have the gauge, they have the whole pressures and equipments, and also infrastructures for the production of submarine. The second batch of submarine is already signed by the government for another 3, and for the 3 next submarines, all will be produced in PT PAL. So at the end of the production of the 6 submarines, so PT PAL is able to do the production by themselves.
Okay, thank you. Maybe the last question from me. Now we are facing industrial manufacture 4.0. We are now facing the digital era, and we know that defense also, we cannot say that digital cybercrime or something. There's any I'm sorry for the. There is any specific strategy from Ministry of Defense regarding about cyber attack or some kind of that, because that 7 priority is like a physical attack. When some kind we go to the war, we need that equipment, but in now like a cyber attack, is it
yes, of course, yeah.
Yeah, can you share about that to us?
Yes, as you saw in my presentation, through Perpres yang terbaru, the newest one 2021, Perpres number 8 2021, there are 3 additional priority programs. Which is one is the satellite, the military satellite. The second is underwater sensors, and the third is the UAV Malay. All of these 3 is to answer the curiosity about the cyber defense, because we want, of course, to be superior in cyber defense, and we put in place these 3 special new priority programs to face the cyber, to improve the capability of Indonesia's cyber defense. I think that's my questions, of course. And then aside from that, if we are talking about UAV drones, also it is not, I mean, not the Malay, the medium altitude, low endurance Malay. Other Malay, there are a lot of types of Malay, of UAV, we also made a lot of UAV in the country, but it is not part of the priority program because it is already in the process.
Okay, thank you very much. Very interesting topic. I hope next time Professor Bondan can give us a guest lecture maybe concerning about this theme. It's very interesting because we know that defense is a very important thing in a country. So we hope from mechanical engineering and department in UNHAS also can join and take a part in that thing.
My suggestion is for your bulletproof vest, you collaborate with, there are, I think, about 3 companies, who work in that area, to propose with them, and then of course you, the collaboration between university and the defense industry is totally on your own. The government will not be take part on that, but if then the industry thinks that your product is something that is feasible to produce in the mass scale, so it can then be put, in the list of the procurement of the government.
Okay, thank you very much for your suggestion, Professor.
Okay, thank you.
Thank you very much.
All the best for UNHAS and especially for the mechanical engineering. Once again, thank you for inviting.
Thank you very much. So before I close this keynote speaker session, I would like to say thank you very much again for Professor SHUZI HAYASE from University of Electro-Communications, Tokyo, Japan, Professor TAWATCHAI CHARINPANITKUL from Chulalongkorn University, Bangkok, Thailand, Professor Noordin Muhammad Yusuf from UTM, Malaysia, and Professor Bondan Tiara Sofyan from National Resilience Institute, Indonesia. Thank you very much on the behalf of IC-EMAMM 2021 organizing committee, saying thanks to all speakers and then to the presenters. After this session, we will go to the parallel session. And then for the participant who joined us today, thank you very much. I hope we can meet again in the next international conference from Mechanical Engineering Hasanuddin University. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Very warm welcome to the Department of Mechanical Engineering at Hasanuddin University, Indonesia. Standing as one of the oldest departments at UNHAS, the Department of Mechanical Engineering was first established on 10 September 1960. It has a long-standing history of providing quality education, with curriculum that offers a strong foundation for students to excel in their careers and ready to compete globally. This department has obtained the national accreditation status, rank A, the highest based on the decision of the National Accreditation Board for Higher Education. With our new campus located at Goa, our students are allowed to have space, fresh air, and the feel of a beautiful atmosphere. The new campus is a wonderful learning environment with dedicated indoor and outdoor learning spaces. As well as technology development through the Center of Technology. They instill a love of learning in our students and encourage curiosity. Teaching and learning is at the very heart of what we do as a department. Our vision is to develop an excellent program in obtaining mechanical engineers that are capable in research, development of science, technology, and art, on energy conversion, mechanical construction, and metallurgy. Our program comprises of 149 of semester credit points with duration of the program in 4 years or 8 semesters. A major part of our teaching and learning activities is focused on student-centered learning and laboratory-based education. With the help of total 30 highly qualified academic staff, diverse range of teaching methods are used for different learning outcome and context, and none of the courses are acquired exclusively by one method. The learning process is also supported by total 11 well-equipped laboratories, a workshop arena, and 3 laboratories as research laboratories to support the final project. These laboratories support the fundamental theory taught in the classroom. Each laboratory is completed with practicum models, and at each practicum, standard operation procedure has also been established for each